Okay, so I'm going to solve some quadratic equations, and I'm going to solve it using, in this video, using the square root method. So the first one I'm going to do is 3x squared equals 27. The first thing I do is divide both sides by 3. So I get x by itself. And so the 3 cancels over there. I get x squared equals 9. 27 over 3 is 9. Next, I take the square root of both sides. And when I take the square root of both sides, on one side, I have to put plus or minus. And I don't do it on both sides because I just cancel out. But on one side, I put plus or minus with the square root. And so the square and the square root cancel. And I get x equals plus or minus the square root of 9, which is 3. Now if I list these solutions out, it's 3 and minus 3. Okay, so that's the answer. The next one, 5x squared plus 1 equals 51. Now, with the square root method, you use the square root method when the x term is missing. Like when it's in general form, if the x term is missing, then using the square root method is good. If the x term is not missing, then we use other methods that you'll see in other videos. So I start off by subtracting 1 from both sides, and I get 5x squared equals 50. Divide both sides by 5. And I get x squared equals 10. I take the square root of both sides. Don't forget the plus or minus. So the square root and the square cancel, and I get 10 equals plus or minus the square root. X equals plus or minus the square root of 10. So if I list out the two solutions, it's plus square root of 10 and minus square root of 10. Next, we have 4, and then parentheses, x minus 1 squared minus 16 equals 0. Now this is something we would see when when we have a quadratic equation in standard form and we're trying to find the x-intercepts. So I would begin by adding 16 to both sides. So we add 16 to both sides, we divide both sides by 4, and I have x squared minus, or x minus 1 squared equals 4. And so now I take the square root of both sides, and I still have plus or minus on one side. And so the square root cancels with the square, and I get x minus 1 equals plus or minus the square root of 4, which is 2. Now I'm solving for x, so I add 1 to both sides, and I get x equals 1 plus or minus 2. So I have to list these out one at a time. I get 1 plus 2 is 3, and then I get 1 minus 2 equals minus 1. So there's my two solutions, 3 and minus 1. I'm going to pull up the graphing calculator to show you how to verify your solutions, just to make sure everything makes sense. And you should always have multiple ways to check your solution so that you'll know when you have a mistake. Okay. So I go to y equals. Okay. Just gotta freeze for a minute. Okay, doing trig last. Come on. Okay, and so I'm going to put in 4 x minus 1 squared minus 16. I'm going to zoom standard. Gives me the nice 10 window. I'm going to do trace and type in -1. And so x equals 1, y equals 0, or x equals -1, y equals 0. The other 0 was 3. And we get x equals 3, y equals 0. So that is the solution. So when I replace y1 with 0, so 0 equals 4 times x minus 1 squared minus 16. Solutions are -1 and 3. Okay, so another example, the next one is 8x minus 3 squared in parentheses minus 5 equals 0. Now this would be kind of weird to see associated with a parabola, but it might happen in other situations and applications. So to do the square root method, we add 5 to both sides. And so we get 8x minus 3 squared equals 5. We take the square root of both sides. And on the side with the 5, it's plus or minus the square root of 5. So the square and the square root cancel. 8x minus 3 equals plus or minus the square root of 5. Next, I add the 3 to both sides. And I get 8x equals 3 plus or minus the square root of 5. And so that's what I have here. Whoops, what was it? 3 plus or minus the square root of 5. And now finally, to solve for x, I divide both sides by 8. So I get x equals 3 plus or minus the square root of 5 divided by 8. Now I need to list them separately, so I get 3 plus the square root of 5 over 8, and 3 minus the square root of 5 over 8. Now real quick, let's see if we can check it. So I go to my y equals, and I put in my new equation, 8x minus 3 in parentheses, squared, minus 5, and I graph it. All right, that parabola looks terrible. So I'm going to go to Window, and I apparently don't need it to be so wide, so I'm going to change it here. There we go. So both of our zeros occur between 0 and 1. Okay, so I have this solution. And then what I'm going to do is I'm going to hit Trace. And I'm going to type in parentheses 3 plus the square root of 5 divided by 8, and hopefully the other side comes up 0. So I verified the 1, 0, the 3 plus the square root of 5 over 8. Now I'm going to test the other one, so I get 3 minus the square root of 5 over 8, and I get the other 0. So it's blinking here on the intercept, and I have y equals 0. So I have verified my two solutions. Okay, the next one, and the last one, so this is the last one, minus x plus 2 squared plus 7 equals 0. So I start off by subtracting 7 from both sides. And now I have this minus 1 here, so if I divide both sides by minus 1, because I can't take the square root, I'll be taking the square root of a negative. So I get x plus 2 squared, and now my x's cancel, or my negatives cancel, and I get 7. Take the square root of both sides. Don't forget the plus or minus. The square and the square root cancel, and I get x plus 2 equals plus or minus the square root of 7. Finally, subtract 2 from both sides. Okay, and so listing them separately, I get minus 2 plus the square root of 7, and I get minus 2 minus the square root of 7. So it's always good to verify. So we go back to our graph, and we do minus x plus 2 and then plus 7. We graph that. Okay, it looks all funky, but remember I changed the window last time. So I go back to Zoom Standard. Opens down, that's good because it's negative. So I go to Trace, and I'm going to enter minus 2 plus the square root of 7. And here it is on this side, y equals 0, so that's a solution. And then minus 2 minus the square root of 7. And we see that is 0 for the y. So those two solutions work out. Okay, and that was the 5 examples that I wanted to show you.